Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to our second tutorial about the program Multisim. In this tutorial, I'm gonna explain to you and solve with you some of the problems that are mentioned in the book. All these problems are related to some examples, and most of the time they ask us to verify the answers that we have answered using the laws. Like here, the first one is about how to use the voltmeter to measure the voltage across the resistor. Of course, as we know, we can measure the voltage here by that VR equals to the R times I according to Ohm's law. So if we calculated 27 kilo ohm times 880 micro ohm, it's going to give us 4.86 volt. So let's see, verify this with using the voltmeter. So to get this toolbar, usually it's not here. You go from View, then Toolbars, then choose Measurement Components. After that, add the voltmeter. And then we click on Run. Oh, it gave us the same answer, but negative. That means I didn't connect the voltmeter correctly. Okay, let's stop this, delete this, and connect it from inside. I hope it gives us the same answer. Play. Okay, it gave us the correct answer, 4.847. If you see in the book, it gave us 4.86. And that there's a small difference, that because here we're like dealing with a real voltmeter that has some resistance, and that will affect on it. It has resistance that will affect on it. Like if you here like change the resistance to 100 mega ohm, it's gonna give us a closer answer maybe. Let's stop the simulation, because if you edit anything on the measurement components, it won't change unless you stop the simulation and run it again. Okay, that's very close, 4.859, and the answer is from the law is 4.86. So you can get in the lab you can get both these answers according to the resistance of the voltmeter using, according to the company you're using. Of course, the companies has different resistance for the voltmeters that are different. Okay, now let's go to the next example. In this problem, we're gonna determine the current through R2 here, and also R2 here, R2A and R2B. And for R2A, we want to verify that it is equal to I2 in the example 514 on page 188. So let's use something different this time. It's called the analyses for the DC operating points. We can get the window for this analysis from Stimulate, then Analyses, DC operating point. So here we're gonna specify the variables in the circuit that we want to measure. So let's see all the variables here. I want the current at R2A and the current at R2B. Okay, sorry, stimulate. So here in this sheet, it gives us the value of the current at R2A, and as we see, it's very close to the current at I2 in the example in the book. The example, it is 50 milliamperes, and here it is 49.99983 milliamperes. That's nice. And for R2B, it is 15 milliamperes. Okay, and by this, we're done with the fourth problem. Now let's go to the sixth and the last problem. As you saw in the previous problems, I had the circuit made from, you can download it from website called, I think, Hall or something like that. I'm gonna give you the URL in the comments. But now here we're gonna build the circuit from scratch simply because we don't have it built for us. It's not on the site. So this problem is the same as example A12 from page 350. In this example, we have an AC current, AC power source and a DC power source, power source or voltage, and we want to determine the maximum and the minimum voltages across the resistor. Okay, what we have done that we added the voltage, the voltage DC, which is stable, always has the same value 12, to the maximum thing that the AC voltage can reach, which is 12, to get the maximum voltage across R, and the minimum, and subtract also 10, which is, and add minus 10, which is the lowest point that the the AC voltage can be, to get the minimum voltage. But also we can get the maximum point and the minimum point from the graph, that it is the voltage with respect to the time. So we can see the waves, the shape of the waves, and then we can get the maximum voltage and the minimum voltage from the y-axis. Y-axis the voltage, and the x-axis will be the time. So let's build the circuit first. Okay, from the book here we had the DC voltage was 12 volt. The AC voltage was given in RMS, VRMS, which was 20 volt. It was 10 volt, and it was not given in VRMS. So if we double click on the AC power, we have to enter the voltage in VRMS, not the normal voltage. So it won't convert. The program doesn't convert the voltage to from the normal voltage, the VP, to the VRMS. So we have to convert it ourselves. Here we have 10 voltage. So 10 times 0.707 is 7.07. Okay. Now to get the graph done for us, we're going to use something called transient analysis. So first I want to show some points here. Okay, so we want to get the voltage across R1. So we want to get the it's going to be the voltage here, 2 minus voltage 0. This is of course 0 because it is grounded, so we want to just get V2, the voltage across the point 2. Okay, so now we go from simulate analysis, then transient analysis. Here we specify the time to start and time to end. Okay, let's take it from 5% of a second. Then we click on stimulate. Okay, I just want V2. So as we can see here the graph, the voltage respect to time. So we can get the point from the highest point here. This is the maximum, and the lowest point here is the minimum voltage. Let's zoom. We can see that the maximum point here is 22 and the minimum, let's see, that's almost at 2. Yeah, it's almost at 2, and here the maximum is 22 almost. So we got the answer, same as the book. Okay, thank you for watching and good luck with your exams, your assignments, the projects, everything. Goodbye.